Okay, so we're going to start off with area. We're going to be talking about a lot of different shapes today. So we're going to call these polygons for right now. Area of polygons. We're going to start off with a parallelogram. So I'm very quickly also, when I am going over each of these diagrams, going to tell you how do we know it's a parallelogram. So a parallelogram often looks like that. These are parallel, and these are parallel. But in order to find the area of a parallelogram, it is the base times the height. So base times the height. Notice this is a small b. Notice this is a small h. You need to make sure that you're paying attention to the capital letters versus lowercase, because when we get into volume formulas, it is going to make a big difference. So I am going to, for a base, so the base would be, I think about what it's sitting on. And then the height, color here, and that would be your height. Keep in mind, think of this kind of like as a roller. So this height could be, if I do the same thing, now this could be my base. Sorry, I keep moving this paper. And keep in mind, my height could be here. This does not become part of the base. This little piece here is just saying that, hey, I'm extending this out in order to get my height. So this height could actually slide anywhere down those. But here is the formula for the area of a parallelogram. Let's move on to a rectangle. So a rectangle is a parallelogram. Rectangle also has the characteristics of 4 right angles. And the formula is still the same. It is base times height. A lot of times you will see it as BH, just no multiplication sign in there. So same thing. This could be my base. And that is my height. Or if you think about it the other way, I could turn my paper. And then this would be my base, and this would be my height. So while I mention that, what I want to make sure that you understand is that the base and the height must form a right angle. Okay, in other words, the base and the height are perpendicular. Okay, so you have to have that right angle indicator. Moving on to a rhombus. Let's do a square first. Moving on to a square. We know what a square looks like. Okay, it's a rectangle, but more specifically, all 4 sides are congruent. So because it is a rectangle, this is still my base, and that is still my height, because I do have 4 right angles in here as well. But there's something special about a square, so it can still be base times height, or what often you will see is that it will say that this is a side, and this is a side. Well, the sides are the same length, so it could just be area equals the side squared. Okay, so either way you want to look at it. A rhombus, I always think of it as a parallelogram that is kind of scrunched up. So it is, still has a parallelogram, so still has the qualities there. So these are congruent, or excuse me, these are parallel rather. but it also has all the qualifications or properties of a square. So all of these sides are also congruent. So much like the parallelogram, one of these sides would be my base, and my height would be whatever is perpendicular to it. Again, this piece does not become part of the base. Another formula for a rectangle, a rhombus, is we have this segment and we have this segment. If you remember, these are called diagonals. So another formula is that area equals 1/2 d sub 1 times d sub 2. So in other words, it's 1/2 your diagonal, or one diagonal, times the second diagonal. Okay, so we have this formula for a rhombus, and we still have the area equals base times height for a rhombus. So a rhombus actually has two formulas depending on what you are actually being given. The one figure that we don't do a whole heck of a lot with, and that is kites. You guys know what a kite looks like. Okay, so in a kite, those two pieces are congruent, and those two pieces are congruent. Much like a rhombus, we have the two diagonals, and in a kite, the two diagonals are perpendicular. If you remember from a rhombus, the diagonals are also perpendicular. So in a kite, it has the same formula as a rhombus. It is 1/2 d sub 1 times d sub 2, or half first length of the first diagonal times the length of the second diagonal. And finally, we have a trapezoid. And in a trapezoid, we have, it might look like that, or it might be a little bit more stretched out. So this would be called an isosceles trapezoid, and this would be called a trapezoid. So either way, you have one set of parallel bases. So this would be base sub 1, and this would be base sub 2, or vice versa. It does not matter. So the area formula is 1/2 the height. Remember, height can be anywhere as long as it's perpendicular. So there's my height, or my h. 1/2 the height times the sum of the bases. So area equals 1/2 the height times base 1 plus base 2. What you are actually doing on this one, half of the bases is actually finding this piece right through here, which is called a median. So you're actually doing the median times the height, just FYI. Another thing you can be looking at is that a trapezoid, if I were to take this and flip it upside down, scoot this up. So I have two congruent trapezoids, and I flip it upside down. What's happening is you are finding, basically, this is a parallelogram. So you're finding half of the parallelogram is what you're actually doing. Okay. I'm going to do a separate video for triangles because I have some other special problems that I want to do in there.